Okay, so today we're going to be learning about natural log derivatives, which is in Chapter 5, Section 1 of your textbook. Okay, so this basically states that the natural log of x, when you take the derivative on the integral from 1 to x, is equal to 1 over t dt, where x is greater than 0. So because of this, we have a certain number of properties. One is that the domain is from 0 to infinity, and the range is from negative infinity to infinity because, the domains are obviously going to be 0 to infinity because x can't be less than 0. The function is going to be continuous, increasing, and one-to-one, and it's also going to be concave down. So when we look at a few of these properties, it also goes on to say, like, natural log of 1, that's going to equal 0. When we have the natural log of a to b, this is also the same thing as saying the natural log of a plus the natural log of b. When we have the natural log of a to the n, we can take the exponent out, and that'll give us n natural log of a. And then we also have natural log of a divided by b. So this is the natural log of a minus the natural log of b. Now, all of these properties are going to come into hand when we start taking the derivatives of the natural log. It makes it so much simpler, and you don't have to use product and quotient rule and everything. Okay, so when we're working these out, when we have the natural log of 10 divided by the natural log of 9, this is just natural log of 10 minus the natural log of 9, and that's just from our properties. So when we have the natural log of the square root of 3x plus 2, this is basically the natural log of 3x plus 2 to the 1/2. And we know that we can bring that 1/2 down. So this is going to end up being 1/2 natural log of 3x plus 2, which might not seem so simpler, but it will end up being a lot more simpler when we start taking the derivatives. So natural log of 6x plus 5 divided by 5 is the same thing as number 1. Natural log 6x minus natural log 5. For number 4, it's the same thing. We're taking down the power. So we have natural log, we have 2 natural log of x squared plus 3. And then for this fourth one, we have the natural log of the square root of 2x plus 1 times x. So this one is going to be, we're going to rewrite to the natural log of 2x plus 1 to the 1/2 times x. So this is 1/2 the natural log of 2x plus 1 plus the natural log of x. And when we have the derivative of the natural log of u, this is going to be 1 over u times the derivative of u relative to dx. And that is basically just saying u prime over u. And that's the way I'm going to say it. And again, u must be greater than 0. So when we look at this problem, it's asking us to take the derivative of the natural log of 2x. So we know this is going to be u prime over u. So we're just going to take the derivative of 2x, which is 2, and put it over 2x. So this is going to give us 1 over x. Now when we look at number 2, it's the same thing. We're going to put this as u prime over u. So what's the derivative of 2x plus 1, of x squared plus 1 is just 2x divided by x squared plus 1. Now for this one, we do have to do a little more work because we do have the product rule. So when we're looking at x times the natural log of x, we have x and the derivative of x, which is 1, and we have the natural log of x. And the derivative of the natural log of x is 1 over x. So now when we put these together, we have the natural log of x plus x times 1 over x. So this is just equal to the natural log of x plus 1. So for this third one, this is where we're going to use the general power rule. So this is equal to 3 natural log of x squared. And don't forget, we have to do the inside. So times the derivative of the natural log of x. So this is going to give us And that'll be our answer.